Let's talk about how much math you actually need for machine learning. The first thing you absolutely need to know is basic algebra and functions so you can understand and manipulate the relationships your models are using. This means getting very comfortable with variables and equations so you can represent unknown quantities and start thinking of a function as a machine where an input goes in, something happens to it, and it spits an output out, which is very close to what actually happens in machine learning. You should know how linear functions and lines work, including slope and intercept, so you can understand how the changing input affects the output. This formula that we use for linear regression models is just a combination of your input features, the weight that the model has decided for them, and a constant shift. And you should also make sure you know exponents and logarithms thoroughly so you can reason with growth, scale, and decay. The next bucket of math you need to learn is descriptive statistics so you can understand and clean your data before actually applying it to your model. Here you must understand all the ways to center a distribution, so mean, median, and mode, and how to measure how spread out the data is with things like variance, standard deviation, and mean absolute deviation. Then you'll also look at percentiles and quantiles to understand range and where individual observations sit in that range. And we use all of these features to pre-process our data. For example, models like logistic regression and many neural networks work so much better when no single feature is dominating just because of its numeric range. And the concepts you learn in descriptive statistics will help you shift and scale your data so that your model can run without outliers or columns with big ranges totally affecting how the model works. So you learn descriptive statistics for understanding and pre-processing your data, and that is what makes the algebraic models you build on top of the data actually reliable. In machine learning, this shows up every time the model's output is a score between 0 and 1 rather than a hard yes or no answer. And a classic example of this is logistic regression. The next bucket of math you should know is probability and random variables, which we use whenever we think about classification and uncertainty. You should learn how to compute the probabilities of events and conditional probabilities, and also fully understand independent and dependent variables so that you don't make incorrect assumptions about how variables interact. Loss functions like cross entropy are measuring how far your predicted probability distribution is from the true label across many samples, so understanding them is really about understanding probabilistic error. You'll also learn about false positives and false negatives, which will help you evaluate the model. So you learn about probability for interpreting model outputs, understanding and creating loss functions, and reasoning about the kind of error your model makes. The next thing you'll learn is linear algebra so you can think about model operations and your entire dataset in an efficient, compact way. So in linear algebra, you'll get comfortable with vectors and matrices, matrix multiplication, and the dot product. In machine learning, this is so helpful when you want to apply a transformation to the entire dataset in just one go instead of going column by column. Neural networks are a classic example of this because each layer applies a linear transformation all at once, followed by nonlinearity. And concepts like distances and norms also show up in k-nearest neighbors or clustering. So you learn linear algebra for representing datasets and model parameters as vectors and matrices, and for understanding those big matrix operations that your model is applying over and over again. Next, you should learn calculus and optimization to understand how parameters get tuned when a model learns from data. And you'll also learn gradient descent, which works to find the minimum of a function by repeatedly taking tiny steps in the opposite direction of the gradient. And since functions like gradient descent are one of the most important parts of a machine learning model to minimize loss, understanding the math behind every part of the formula is vital. Now, this is not to say that you need to be an expert in all of these 5 buckets of mathematics before even attempting machine learning. Just make sure you understand the basics first, and so much of the knowledge will come when you actually get your hands dirty. Altogether, these areas of mathematics support a full machine learning pipeline from raw data to interpreting results. So if you learned something from this video, don't forget to save it for later and follow for more breakdowns just like this.